Okay. These are the same graphs that we use to analyze velocity. Now we're just going to look for non-uniform motion. So remember, uniform motion meant that an object was like at cruise control, right? So an object that's accelerating is not on cruise, right? You know, if you want to get faster, you have to come off cruise. Maybe some of you have already started driving, right? That's a scary thought. Okay. So let's look at these position time graphs. Okay. Now, what do you think? What's happening in this one? How could we describe? Please listen. I don't like talking over you because I feel like I have to talk louder and then it hurts my throat. Okay, what's happening in the object's motion here? Carson?
It's like speeding up, and then when it reaches its speed velocity, it just goes.
Okay, yeah, so there, it seems to be like a bit of a speeding up here, and then a deceleration here. Yeah, okay. What about just this one? What's happening there?
He's just giving her.
Just giving her. What does that mean in sciencey terms? Acceleration. Okay, so here, there's positive acceleration because velocity is increasing with time. So we would also note that the slope is increasing. So as we go up, our slope gets steeper, right? So at this point, our slope is not very steep. Here, slope gets steeper and steeper and steeper. Now we won't be doing really slope with this kind of graph because it's a bit more complex. But all right, what about this one? What's going on with this one? The velocity is decreasing, so it's decelerating, right? It's kind of slowing down. So this is a negative acceleration because it's decelerating. The velocity is decreasing with time. So we know that slope is decreasing. Because even look here, it almost starts to level off to being no slope at all.
Wait, why does it say acceleration at the top?
Acceleration graphs at the top?
No, at the top of that graph. Top of that graph.
Because this is a good question. This is actually a DT graph still, but it's showing acceleration. That's what it's saying. Yeah, good question.
So it's
It is a position time graph or a displacement time graph, but I just copied this picture because it says it's showing acceleration. It's not a good title for a graph. They should have said displacement versus time. But
so the slope is decreasing even though it's still going up.
yeah, so it means like it could be going in a positive direction, but see here it's kind of steep, the slope, but then look at it's leveling off to almost being horizontal.
So it's decreasing.
Yeah, slope is decreasing. Right? Because remember we said that slope is steepness. Right? At this point, if I was to draw a line, that's kind of steep. But if I was to draw a line here, that's not very steep at all. So here it's steepish. Here it's like horizontal, so it's almost zero. Okay, so next is a velocity time graph. Now, when we look at an object's motion with this velocity time graph, what can I say is happening here? So remember, this is velocity now, not displacement. So what's happening? First my velocity is 1, then 2, 3, 4, 5. So I'm increasing, so this shows acceleration, right? This is acceleration. Actually, let's do this. Let's put this is section A, this is section B of the graph, and this is section C of the graph. So section A shows positive acceleration. What's happening at B? It's uniform motion. Very good. And what's happening at C?
Negative acceleration.
Negative acceleration because it's slowing down in the positive direction. So negative acceleration. Okay. So when we look at a VT graph, that's what's going on with acceleration. Is everyone good with that note? Yeah? Okay. So now let's look at these two graphs. So here, this is positive acceleration, because velocity is increasing with time. And here we have negative acceleration, because velocity is decreasing with time. Okay, so now, so that's just interpreting what a graph is saying about an object's motion. So there will be a question on the test tomorrow where I'll give you a VT graph, and I just want you to tell me about the object's motion. So just like we did, you just tell me it's positive acceleration or it's uniform motion. Just something very simple like that, just like we did.
It'll be a VT?
Yeah. Okay, so now we can, as I kind of alluded to yesterday, we can take these graphs and actually calculate acceleration as well.